Hey everyone, welcome back. We are in grade 5. This is unit 3, lesson 13. Now, a lot of the lesson is just giving us more practice doing story problems. So if you are looking the first part of the lesson and you get confused, I very much encourage you to go back and watch the Magic Math video that's going to help you because that method really is like magic. That's why we call it that. It works like magic. When you follow a system for when you say, I don't know, I don't get it, that's a system to help you get it. There is a part, though, in this lesson that's talking about line plots. And so, because this is a little different, something we haven't done much of, this is what today's lesson is going to be on line plots. So, take a look behind me. If you're looking at something like this and you're like, oh, yeah, I've seen that before, well, those are called line plots. It's on a line. And plot it just means they plot the information. Plotting means putting it onto a graph or onto a table. So they're plotting the information on. So this is a line plot. So there are a few things that we need to do when we encounter a line plot. And you might find that you actually use a line plot. You create one. But if someone gives you one, they want you to interpret it. They want you to analyze what's going on, what the data show. So let's take a look at this and let me give you some background. When I was in high school, we had a fundraiser where we sold candy bars to earn money for our organization. It was the National Honor Society. And at that time, it was okay to sell candy bars. I know some schools now have rules where you can't sell things that aren't like healthy snacks. But back then, we didn't have that rule. So still today, some organizations will sell candy to earn money for their organization. So we're to say that we're having a sale, a fundraiser, and we're selling candy bars. So take a look. This is each day of the sale. The first thing when we encounter any kind of visual data, whether it's a table or a map or a chart or a graph, or in this case, a plot, we first need to see what are we looking at? And how do we know that, what we're looking at? We know that by reading the labels and the titles. So it says each day of the sale. So we know that this is day 1, day 2, day 3 of the sale, day 4. So we can tell, since there's 5 days in a week, we can tell that this was a 2-week long sale. Day 1 through 5 is 1 week. Day 6 through 10 is a second week. Now, and I'm talking about 5, just not 5, like including the weekends, just like 5 days of like the school day. Then over here, it says X equals 1 candy bar. Well, that's really important because when we look, we know each time we see an X, that means 1 candy bar. So we're going to look at number 1. This is day 1. On day 1, this person sold 1, 2, 3, 4, and each X is worth 1, so they sold 4 candy bars. On day 2, they sold 2 candy bars. On day 3, they sold 7 candy bars. So that's the first thing you have to do is you have to just read the graph or the chart, or in this case, the line plot, and get some information, some basic information from it. Then, a lot of times they want us to be able to answer questions about it. So some questions that they might have might be, how many candy bars did this person sell on day 8? So we're going to look and see each day of the sale. There's day 8. Each of these is worth 1. 1, 2, 3, 4, 5. So the answer is they sold 5 candy bars on day 8. Another question maybe would be, how many days did they sell more than 4 candy bars? That's a hard one. We can't just grab the information right from the line plot like we just did on day 8. We're looking for more than 4. Does number 1 count? Is it more than 4? It's exactly 4. So we can't count that. That's not a day they sold more than 4. What about day 2? That was less. They only sold 2. What about day 3? Yeah, so we're on 1. There's 1 day so far that they've sold more than 4. What about 4? Day 4, they sold 5. That's more than 4. What about day 5? Nope. What about day 6? We can just tell by looking, right? We don't even have to count them. That's definitely more than 4. So we're up to 3 days. Day 7, again, that's the highest one. We know that definitely is it. So now we're at 4. Day 8, there's more than 4 there. So now we're on 5. Day 9, no, they only have 3. Day 10, yes. So our answer is 6. How many days did they sell more than 4? And the answer is 6. But we had to look at each piece, each group of data, and think about it. So some of them are write their questions and write their answers. And you might know those terms from your reading. You might say, oh, my reading teacher talks to me about an answer that's right there. It's written right in the text. But these are kind of think and search questions. We have to think about what the question is asking us, and then we have to sift through the data, search through the data to see which ones match. What about a question like, what is the combined amount? These are, again, tricky think and search questions. What is the combined amount that this person sold on days 6 and 7? What does combined mean? Puts together. So the combined amount is when we put that information together. On days 6 and 7, we have to sift through the data, don't we? We're not interested in day 1 through 3, 4, 5, and we're not interested in 8, 9, and 10. We're interested in 6 and 7, and what's the combined sales on those 2 days? Means when we put all of the amount that we sold together, we put it together and combine it. How much was it? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It was 17. But do you see how the answer wasn't right there? We just couldn't grab it. Like as if I said, how many did we sell on day 2? On day 2, we just look at day 2. We say 2. That's easy. Even something like, how many more did we sell on day 1 than day 2? Still pretty easy. How many more on day 1 than day 2? We see day 1 was 4. We see day 2 was 2. 4 minus 2 is 2. But some of them get trickier. And the more we analyze the data, sometimes the trickier we can be about finding information from it. Okay, so let's turn to questions like most and least. Which day did we sell the most? Well, we can look at the relative heights to determine which one it was. We can tell just by looking at day 2, day 5. Those are the lowest ones. Day 9, those aren't it. So we're looking for the one that has the most. So right away our eye is drawn to number 7. It's the tallest, so it has the most. On day 7, we sold the most number of candy bars. So that's an easy one. What about the least? Least means the smallest number. So same thing. We're not looking for the big one this time. This time we're looking for the ones that are really low down. Our eye is drawn to number 5, the least. Now, once we start analyzing the data, this gets a little trickier and we can find some interesting information. For instance, we can do multiplicative comparisons. Yeah, those are big words. Multiplicative comparisons. That's when we talk about how much more something is, as in multiplication or division, how many times more. So we could say on day 1, we sold 2 times more than we did on day 2. We hear those words 2 times more. Means we take what's on day 2, we multiply it by 2 because it's 2 times more, and that's what we get on day 1. Day 1 has 2 times more than day 2. What would be the multiplicative comparison between day 7 and day 9? Well, day 7 has 1, 2, 3, 4, 5, 6, 7, 8, 9, and day 9 has 3. Remember when we're talking about multiplicative comparisons, how many times? 7 is 3 times more than what we sold on day 9. On day 7, we sold 9. 9 is 3 times more Then day 9. Day 9 was only 3. What about going the other way, thinking about fractional parts? We could say on day 9, we sold 1/3 as much as we did on day 7. 1/3 as much. Because 7 divided by 3, or times a group of a third, is 9. Oh, I'm sorry, it's not. It's what it is on 9. Is actually the number is actually 3, but that's what we sold on day 9. So those are tricky things, but it's kind of fun to use those words of how many times more or how much less, and not just adding and subtracting, but rather thinking of groups of multiples of. And then finally, we talk about some statistical analysis, finding the mean, the median, the mode, and the range. So, what's the range? The range is the biggest number or the smallest number. So, the smallest number we sold was 1. We didn't sell 0 on any days, so that was kind of good. The biggest amount we sold, well, so on day 5 we sold 1. There's no zeros. We don't see any empty spaces. So on day 5 we sold 1, so that's the smallest amount. And on day 7 we sold 9. So the range is from 1 to 9. How much is the range from 1 to 9? 8. Yeah, that's the difference of the range. What about the mode? The mode is which one occurs most often. Which data point occurs most often? Well, again, when we look, it's easy to tell which one has the most. 7. There's the most. That was the number that was highest. But don't let that trick you. That's not the one that occurs most. Is there any number that occurs more than once? Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the mode in this case is 5 because there's 2 5s. And there aren't, well, hold on. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Nope, that's not it. Yep. So there's 2 5s. So the mode is 5 because 5 occurs twice and every other number only occurs once. What about finding the median? The median, remember, we have to take the top number and the bottom number, get rid of it. Then the top, we have to put them in order. Then to the top and the bottom and the top and the bottom. So tune into another video for some more specific information about finding the mean, the median, the mode, and the range. This is more just on how to read a line plot, but you're on your way. And don't be surprised if they give you questions like that. Mean, median, mode, and range, the statistical analysis. Now, the last thing I want to tell you, and I could have maybe told you this at the beginning too, but we talked about it just a little bit, but we have to know sometimes they'll give us a line plot where it's not 1 to 1. It's not that X is 1 candy bar. They might say, no, X isn't 1, it's 5 candy bars. They might change it so that when we're interpreting the data, we're not saying on day 1 we sold 1, 2, 3, 4. We're not doing that. If they tell us that each of these X's equals something else, like in this case 5, now on day 1 we would say, back to the easier questions, how many did you sell on day 1? The answer would be 5, 10, 15, 20. So the answer would actually be 20. We sold 20 on day 1. So you have to make sure to really look and read the labels so you know how much everything is worth. I hope this has been helpful for you for reading and interpreting line graphs or line plots, and we'll see you next time. Bye.